Hello, and welcome to Interaction Design Module 3 Tutorial 2. What are we doing today? So, if you recall last week in Tutorial 1, we looked at P5 keystroke interactions. So, interactions that included different keyboard strokes like the arrow functions, or the arrow keys, the spacebar keys, even a little bit of mouse press. Today in Tutorial 2, we're going to be looking at interaction using the Makey itself. So it's much more of a physical tutorial today. We're going to go over a bunch of the sort of theory behind it. And then next week, we'll be completing the module and completing the term, looking at integrating the two of them. So for this week, week 11, we're going to be looking at the Makey interaction. We're going to be experimenting with materials and interactions. We're going to be using the code directly from Activity 1 to connect and test our ideas, and also going to be considering these ideas of affordance again, right? Like you can basically add an affordance to your Makey and turn it into some kind of a more meaningful interaction. So this means that we are really going to be looking at a lot of different ways we can use materials along with, of course, the star of the show, the Makey. We're finally getting around to using the Makey. And in this image, what I want to point out is this should be everything you have. I'm not sure if you can have those little white wires at the bottom, but you definitely need to have the Makey. You need to have that red wire that is the USB cable that will go from the Makey to your computer, and you need to have a set of full alligator clips, which means clips on both sides. Along with that, we've sent you guys some of these kinds of jumper wire alligator clips. These are things that are potentially useful going forward with the Makey. It allows you to actually connect to a lot of the pins that are sort of on the back side of the Makey. We may not be using these super directly right off the bat, but we may also end up being able to use these as we connect the Makey to other kinds of things, like copper tape, which we're going to be able to reuse now. So if you still have copper tape left over from your project 1, this is a perfect time to go back and use it. If you don't have any, you don't necessarily need some for this. It's really going to depend on what you do at home, but do be prepared to experiment. So if you liked the copper tape and you used it all up and you want to use it for this project, you definitely want to get more right away. We're also going to be looking at other materials, right? So just like Project 1, there's a lot of different materials that can be recommended that really all depend on the level of experimentation and exploration that you're going to go through. Be prepared to use Scotch tape, double-sided Scotch tape, heavy-duty double-sided tape, and possibly even some fabric tape. It's also a good idea to look at what recycled materials you have handy and be prepared to utilize the things that you have and repurpose them for this project as we explore materials along with the Makey. And remember how we broke down those found materials using sizes and shapes, because I'm not necessarily going to go through that today. And you may need some additional tools. So before we jump into the physical fabrication, let's do a quick review of how this is going to work. So in Module 1, we created simple circuits with coin batteries and LEDs. So let's simplify the images down so we can reinforce some of the concepts. We used copper tape, not wire like this, but it's basically the same kind of circuit. And we connected a power source to an LED. And direct current, remember DC electricity, flowed out of the battery to the LED and then back to the battery in a loop. The main point of the project, however, was to create an interaction or use an affordance that functioned as a button or switch. Now let's compare that circuit to the Makey and look at how electricity flows here. Instead of battery, power is supplied and data then is read through the USB cable that is connected directly to a computer. Electricity flows out to the arrow, the spacebar, and the click pads on the Makey. These are like wire connections. Along the bottom of the Makey is a ground or negative. It is labeled earth. This is where the wires then reconnect with the Makey, completing a circuit. Electricity flows out from one of these pads. If it then flows back in to the earth pad, the Makey interprets that as a specific button press. The data simply tells the computer which button has been pressed. Each pad or button represents a different keyboard character. Therefore, the Makey has 5 keyboard pads and 1 mouse press pad for easy button interaction and development for us. And you can see how our P5 sketches that we have easily will work along with the Makey. We use alligator clips to extend the pads outwards, and the wire inside these the alligator clips is conductive, allowing electrons to flow out and then back in. So remember that electrons are units of energy, and conductivity is just a way of describing materials that allow this energy to flow easily. Connecting any of the keystroke alligator clips with an earth alligator clip will complete the circuit. This means that the button or switch interaction requires holding the conductive metal part of both alligator clips, and that the electricity flows through the human participant, completing the circuit. In the Makey circuit, you are the switch. It also means you'll need to strategically use other conductive materials to experiment with. And the emphasis is to create meaningful physical interactions to work with your P5 sketches. So the things that we're going to be building are actually prototypes. And if you recall some of the commentary that we had used earlier in the term when we were talking about prototypes, they are used for testing ideas. So what is a prototype? A prototype is a tool made to test a design or concept for viability. A successful prototype is just an efficient way to look for answers to design questions. Prototype is a term used across multiple design disciplines, and we use it in IXD to describe many different ways of overcoming design problems. In this project, we're going to be comparing this idea of low fidelity prototypes and high fidelity prototypes, but similar to Project 1, we're going to be focusing on low fidelity. So low fidelity prototypes are using the materials around you in order to develop a UX and an interaction. A high fidelity prototype has gone through a full manufacturing process and has been highly tested before it's ready to be commercialized. So this is a prototype, and this is a prototype. The Makey prototypes we're building are low fidelity. Low fidelity does not mean poor craftsmanship, and low fidelity does not mean non-functioning. So these lo-fi prototypes, paper model or paper prototypes work great, and you can do that here. Lo-fi prototypes should be quick and dirty. You think about this from the form storming language we've been using, where you want to experiment with a lot of things to find out what works before you invest a lot of time. Repurpose objects whenever possible, and look for materials that are fast and easy to work with. Found materials can of course be used. So this would be a banana piano lo-fi prototype. Let's jump into the fabrication part of the tutorial. So to begin with, I'm using the code straight up the way that I gave it to you guys. I'm going to be focusing on using the Sketch 6 for sure. So the one that has that sort of like final sound and visual. For the next tutorial, I'll play with that more and show you guys some, fun things you can do with that kind of thing. But that's the main one that I'm going to use for testing, and then everything else I'm going to be doing is going to be focusing on physical testing. Okay, so just to kind of go over what that looks like more than how it works. If you want to know how it works, you got to watch the tutorial from last week. So I can kind of drag that over so it's a little more in the center like that. And if I press the arrow, So again, mechanical keyboard, you know, loud and clunky and not great for that. Okay. So let's take a look at what else we have going on here then. Let me grab this. All right, so here's our makey that's set up. And I'm just going to maybe move some stuff around here. That'll do. So just like we were talking about, I have to ground it by touching the earth, and then I'm going to... Right? Elegant, fun, but what can we do with it? So the first thing I thought that maybe would be worth doing, I'm just going to kind of drag that out of the way. Let's reduce that. We don't need it. This is, you know, one of those ones from Module 1. The an unused LED one that has, you know, I didn't finish that. I'm actually going to take off the LED so we can use that for something else. And you can see what's left here is some copper tape. Now, I'm going to focus on this area here being the sort of button press, and I'm going to just clip that out a little bit so that it's accessible sort of right from the edge. Now, let me grab a couple of alligator clips. The black one might not be the same as the one you guys have. Let's talk a tiny bit about alligator clips. On the inside of these alligator clip wires, it's just wire. Like on the inside, it's basically the same no matter, you know, what color. So here's like a yellow one, and here's a white one, and here's a green one, and you may have blue with yours. You never know, right? They come in a whole bunch of different colors, and you'll find that sometimes the sheath that's here slides off this way. The purpose of this sheath is just to protect, in fact, the conductive part, because anything that this touches is going to transmit electricity. So if, in fact, two of them touch where you don't want them to touch, it'll sort of break the circuit, right? So what you often need to do is, and if it does this, you need to kind of get it back in there. And there's no super easy way to do that. You kind of have to force it over. There we go. And then you have a much smaller surface. And with that smaller surface, it's less likely it's going to get bumped by some other conductive thing and kind of break it, right? So what do the colors mean then? So the colors are, in fact, symbolic. And more than anything, it just allows us to differentiate colors so that we know which buttons are which. So you might want to use 5 different colors. However, as you're going to go forward learning about electricity, and especially next year when you're going to work with your Arduino, it's important to understand that, in fact, we do use colors very symbolically in electricity. They're not just random, right? So, in fact, things that are in the ground, like the earth part, are always going to be black or green. Green is ground, black is ground, and that's it, right? So, always connect that, and it doesn't mean, like I said, it's exactly the same on the inside. It's just the color and the symbolism of the color that we use. And that way, if I'm looking at yours, like let's say, or any of the instructors, if are looking at your work and you're trying to show, you're debugging, there's a problem, can easily identify which you've connected as the ground and which you've connected as something else. And if you just have random wires stuck to your makey, then it becomes a matter of deciphering what you actually mean to do. So in this case, I'm going to use, well, you know what, because we have red, normally I would use red for voltage, but you know what, like I mentioned, you can use 5 different colors. I'm going to use maybe yellow. And let's start with maybe just the down arrow, right? So you can see how quickly and easily the makey allows you to connect those things together. And if we touch them, oh, let me bring the, let me just move some, whoops. Oh, right, that's trying to do a down arrow. I better be careful when I do that. Bring this back over. That's what I mean about conductivity. You have to be careful. It actually thinks that the mouse is... There we go. Okay. So now I should be able to, and either one of these could be ground. And what I'm going to do is I'm going to connect my makey alligator clip, the ground one, to one side. And I'm going to connect, actually, you know what? I'll put it on the other side. Put that there. Put that there. Let's see how well that is working. Perfect. So that's my first makey circuit, right? And you can see how in fact, the copper tape allows for a maximum amount of conductivity, and the electrons are flowing through it. And when I touch, the electrons flow through my finger and up the other side. And now there's a loop that's happening there. Okay. That also, it's important to understand that the teeth that are in those alligator clips dig into the copper. And in fact, no matter what material we use here, we should be able to do that. So from this, what we could actually do is create multiple buttons that are connected to the ground. So you only need one ground wire, and that's why the earth on the makey is one long one. They're all connected. But each of the keystroke buttons is its own circuit. So as you touch those individually, that's where that would work. So what I'm going to do is I'm going to just like quickly play with this, and I'll just record it and maybe to put it in sort of like fast motion or something so that you guys can see how all that is going to fit together. Make a little tiny bit of the little back tape. Remember, if you get your hands on some of that, you need to take off the first, 7 inches before you get to anything that is functional. So, I need to put it on here. I'm not taking any very long amount of time to work on this. I will have to. Because how close I have these alligator clips, I do need them to be fully sheathed. So you'll see me kind of like quickly put those back on. Right, let's put there. And of course, once you get all these wires connected, it gets very messy that way. Alright, and each time I do that, I'm going to bring over just enough. Okay. Let's add another one. And I'm just approximating how much copper you need here. And I definitely don't want it to touch entirely close, but not. And that's obviously like, gosh, it's so messy now, but it'll work. So, oops, I need that. Add that one. Put the white one here. Take the window. I think this one may just come down from there to there. And I may not have another color to differentiate. Somewhere I have blue and other colors, but not handy. And use yellow. What other ones do I have here? I guess I'm just going to use another white one. I mean, you could use all white ones if you want to use whatever colors you want. Like I mentioned, it don't matter. I would just not use black. Just, as a thing. Could add the one on this side if you wanted to. I'm going to just add another one right here. I'm going to put it on the space bar. That's where the code is written to use it. Okay. So this should give us the entire octave range that we're looking for, clean enough to kind of see all the pieces of the puzzle. Let me bring the code over so we can kind of experience that entire thing all at once. Clicking inside the browser window, of course. Perfect. Okay. So one of the things that we'll be looking at, of course, as we go forward is how to make this more meaningful. Like this is really just a test just to prove that the copper works well. Testing the material. I'm just using like a paper construct here. So next it would be looking at another way that we could do this kind of thing using maybe slightly different materials. So for this next stage, I thought we would take a look at another really good conductive material, which is graphite pencil. So these are, if I hold them up, you can see, let's see if the camera will grab that. Not easily, surprisingly. Anyway, that says Curry's Artist Graphite. So Curry's is a store here it's an art supply store here in Ontario. And so, although the lead on that looks like it might be coming out a bit, we'll see what we can do. And one thing I want you to notice is that it says, if you can read that easily, it says 4B. This right here says 4, oh, you can see it a little bit there, 4B, right? I have a 4B and I have a 5B. And the way that graphite amount in a pencil is measured is actually through this idea of B for soft and H for hard. And for this project, you definitely don't want anything that is going to be let me explain. So an HB is exactly balanced. It's neutral right in the middle, right? 1H, 2H, 3H, as you go up that level, it gets harder and harder and harder. And hard pencils have like really good uses. And then going below that, you have like 1B, 2B, 3B, 4B. I think it goes all the way up to like 9B. By that point, it's almost like just like soft, almost like charcoal, right? So in this range, in the 5B, it's and you'll see like I can actually like it can come off on my finger. So optimally here though, you need to have a certain amount of graphite down in order to have enough conductivity. So if you just do, and we can test this, and this is why you want to test this. You want to get yourselves a 4B, and I would also say, unfortunately, you really do have to test it sometimes in the store. So what I've actually done is I've gone and done a certain amount of testing in Curry's, and I've sat there with my laptop open, connected my, had a piece of paper, and then drawn a little bit with it, had my alligator clips on it, and was able to test it. So I know that this works, but there were other 5Bs or 4Bs that didn't work, right? So I've actually tested this one quite a bit. But let's start by just doing a line, right? So we're going to put a line there, and we're going to put a line here. And I'm going to take this black one, and I'm going to attach it to that line the best I can. And I'll take one of my other yellow ones, and I've got that. Let's see. No, nothing's happening, right? Although let's also, pull this in here just to make sure. Sorry. Nothing, right? So here's why there's nothing. There's nothing there because there's not enough for the alligator clip to grab onto, first of all. So you have to really give it a little bit of something. And it doesn't have to be clean, to test with. So let's now test that. So now there's some stuff there, right? Let me bring that up here a little bit so you can kind of see, right? There's a little bit there now of graphite that the alligator clip can bite onto. Let me grab the yellow one there as well and put that in there. Okay, now let's see. Does that make any difference at all? There you go. Just even that. So even with this, one stroke of that pencil, and there's enough. Oh, it's funny. So this thing, oh, you know what? There was a little bit that was the finger that had the graphite on it, though. Yeah, no, it's still doing it. Now, if I make this line a little thicker, right, and I make this line a little thicker, That's even better, right? So, what does that mean? Well, it also means that as long as you treat it like a circuit, right? Like you could come in and play with your lines. Got another one. Actually, so this guy here, I'm going to put there, and that guy here, and that guy here, and that guy here, and that guy here. They might interfere with each other. That's not the best way to design it, but... Oh, let's go ahead there. Right? And that's how quickly you can create something using like a nice pencil. Right? So you could actually also, it means you could actually design this completely separately and then just bring it in and then trace your material with your pencil on top of it. As long as you don't connect them, as long as there's a little gap between them, then that will work. So let's add in another. Right. And let's add another one here. Let's do a test for something like a bit longer. Let's see what happens. What happens if we're like all the way to the end here. How about the other white one? Long enough? Red one. A bit longer there. There we go. So you can see that those are all working pretty well, actually. So I'm going to now use this 4B. Let's see the 4B. I can feel the difference. Like, there's quite a difference in the 4B and the 5B. Like, the 5B is so soft that it almost just melts right off. And the 4B has definitely a little more. You can see also I'm getting carbon or graphite on my hands. Working with it's going to be messy, which is also why we're not doing the graphite paint, unfortunately, which we would do if we were in person. Love graphite paint. Like, it's amazing. Okay. There we go. Right? So now you can see how we can use the copper tape. We can use the graphite. Of course, none of this is being used in a meaningful way. This is just showing you technically how they work together. This is not even a well-designed circuit, right? Like, these things are like, especially with my big clumsy fingers, this is too close together, so they're creating some of those, like, kind of blends them together in some way. Anyway. Next, we're going to look at how we can use something that's maybe a little more wearable and see what we can do with that. So, in this case, I have this interesting rubber glove that I bought years ago just because it's actually a good outdoor glove. And this is all rubber coated. And the interesting thing about the rubber coating is that exactly the same as the plastic coating that's on, or even the rubber and plastic coating that's over top of the alligator clips, rubber is non-conductive, so it actually like insulates and holds in, which is why like the two, these alligator clips can touch each other and they don't conduct electricity back and forth and complete the circuit or arc the circuit or break the circuit or anything like that. And that's how all of our electronic components work. It's not that everything we use is conductive. Many things we use, in fact, to control the conductivity are non-conductive. So I thought this glove might be good for that. The other thing is that I'm right-handed. It's a right-handed glove. I've kind of cleaned it up a little bit. You may want to buy a new glove. Maybe you want to find a glove. The other thing about this glove in particular, though, is that it fits really snug for me. So like if I put it on, it's even though like it's a little bit tight around the fingers, like any glove probably would be, what's nice is that it's not like a big heavy work glove. So I have a certain amount of dexterity that I can still do with this glove, and that's kind of the point, right? Now, remember that when we're working on that shoe, I also have to be careful because see how I have to pull on those fingers though, because it's insulated on the inside, and so whatever I do here, I'm going to have to be really careful with getting it off and on, and it may not work. And so this is just sort of the first one that I'm going to do some testing with. So I'm going to start by thinking about, in the end, I may end up mounting a makey like directly onto the wrist area here. And in the meantime, and we have like the 5 keystrokes, and what I'm going to do is I'm going to end up putting probably some copper tape just on, like directly. I might actually just put some copper tape on a piece of paper, and then I can use that directly with the ground. So I'm probably going to prep that one. Actually, you know what? I better prep it first. So if I was doing the conductive paint, this would be actually an amazing place to do that exact thing. Let me think. How do I want to do this? I guess in the meantime, I'm just going to run a piece of copper, like a copper ground, right across the entire piece of paper. Oops. There you go. Caught itself a little bit on the end there. I'm going to just run that right there. And I'm going to put that on there. Okay. So that's going to be my sort of like test for my ground. Then I am thinking that I kind of want to extend the wire length from the Makey quite a bit. So I'm going to just give this a try. I'm going to try taking, gosh, and it's so, I can't believe it used, I guess black on the end. Doesn't really matter all that much for that one. Sure, so I'll use that one for now. So I'm going to connect, I think for now, I'm just going to see what happens. Actually, let me use the yellow one since I'm using yellow wire. This allows me, see how I can like take this and I can actually have the, let's see if I can get that in focus a little bit for you guys to see it. Can you see that a little bit? Let me try to zoom in, see if that helps. So I am, well, it doesn't want to zoom in. I'm connecting that alligator clip to the other alligator clip jumper wire. Okay. Instead of putting this in some pins, I'm actually just connecting it right there. And then this, I'm going to tape on to, in fact, that's exactly how I'm going to do this. I'm going to tape this onto the back. And then from the taped on the back, I'm going to have some copper that goes around to the front lip. Let me do a little test for that. Let me unzoom this out a wee bit so that you guys can see a little more of my, sorry about the jiggling. My phone is mounted above me here. Okay, let me, I don't know yet how well the copper is going to adhere to the rubber of the glove. I may not like it at all. It may take some effort to make it stick. Better than expected, to tell you the truth. And I'm going to attach my alligator clip to it. Perfect. Now, I don't want the alligator clip to break that, though. It'll dangle around and damage it. I'm also a little bit hesitant about the double-sided tape. You know what? I'm just going to give it a tiny try here. I'm just going to put a little bit of it down on the glove just to see, does it add anything to hold that in place. A tiny bit. You know, a tiny, tiny bit there. Now what I want to do is take a bit of the fabric tape. Oh, you know what? Now that I'm thinking about it, so here's my fabric tape, and oh yeah, let's bring in some heavy duty tape. I can see that being handy here. Okay, and I'll test them out a little bit individually there. So let's get a nice clean piece of the tape. The fabric tape is cut very nicely. Let me zoom out a wee bit more if I can. There we go, it's a little better. Okay, let me. Second hold. Amazingly. That's pulling up over there too. I think I need the regular tape handy. Let me do a test of this idea before I go any further. If you're not going on just on assumptions, right? So let me try to put this glove on. Ooh, you can hear that stretching, right? Oh, the fabric tape's not doing great. The copper is pulling up a wee bit there. I may have to put the double-sided tape down for the fingers. Oh, and when I bend, look at that. When I bend, it wants to pull up. So in fact, I'm going to need to think about it being a little more. Oh, in fact, if I bend that too much more, it'll break that. Right? Absolutely break that. All right. So let's test though. If I connect it. and I go in, make sure I'm in on the screen here. All right, let's just test it. Okay. So, in theory, that will work. Getting this connection though to hold up so that you could play with this without worrying about it falling apart, that's going to be definitely the part that pushes this project. You already see, like, look at it, it's just flimsy and falling apart. So that's actually the emphasis now, is figuring out how best to connect these pieces together so that they don't want to fall apart that way. So you could use this if you wanted to play. So now here's the hard part, is let me see, like, what's it going to take? Yeah, like even when I go, I need to pinch the glove to pull it off. And as I squeeze it that way, it just pulls that right off. Okay. So I'm just going to take that off for now. It may be, in fact, that I do need a different glove, or to rethink this part of the process a little bit different, just because there's no way I'm going to be able to get that glove off and on. Okay, but that was a great experiment in order to get to that place, and that's why you do it quick and dirty, right? Like, doing this informed me enough about what some of the variables were that I'm going to need to overcome, so that I, like, for instance, I have to decide, am I prepared to cut this glove up? Cut this glove up, right? To cut the fingers off, say, something like that. And I don't think that I am, so I may have to rethink how I'm going to attach this to my hands. And maybe it's, in fact, maybe a glove is the wrong idea of a wearable for this entirely. And what I actually need is almost to build like some kind of little plastic harness or something like that. I'm going to play a little bit and see what I come up with. So the next iteration is definitely a lot uglier. What I've done here is actually use some of the fabric tape around my thumb to create sort of like a bigger, almost like its own little glove finger, right? Put some of the copper tape across it. I did put some regular tape along the tip there so that it was not sticky on the inside, and I've put the alligator clip with that exact same piece of fabric tape on there, and you can see that I've actually connected it on the other side to the alligator clip. Really ugly, not that hard to get on though. And then let's see, well, it did work a second ago. I need to click within the window there. It works, but there's too much of the stickiness of the tape that's interfering with the touch. Not bad from underneath. Interesting. Okay. Underneath it actually feels a lot better than on this surface area here. This, in fact, feels like it's a waste of what's going into that part of the touch. So I'm going to keep practicing, keep trying things out. Okay, so the 2.0 version is much, much cleaner. So you can see that this original one, I was using a lot of this weird sort of like tape around it. The shiny part shows you that. You can see in the second one, I've really just focused on this sort of fabric tape and really kind of cleaned up the way that the clip itself was attaching to it. I started off with my thumb just so that I had a large enough thing that when I put my index finger in, it can easily slide in and out without anything getting in the way. It's much cleaner all around. You can see how I've enclosed the tip of it. It's basically like when I was talking about cutting the tip off the glove. It's basically like that. Like I've created the tip finger of a glove, right? I've connected it. Now this part, the connection part, is not great. In fact, I would say that in general what I need is like something on my arm, and maybe that's where the makey will have to attach. I'm going to need something I can put on my arm that I can then have these wires go to, and that way I can easily use, if I have like, all five, 4 fingers and a thumb inside this kind of setup without having wires getting everywhere. But you can see that if I click, sorry, let me just use my other hand to click in here. right? So that's working really good. So what I'm going to do, I'm actually going to make a full hand of this and then see how that goes, because it's working out so far. Oh, oops, what am I thinking? Yikes. That would have been awful. Let me peel that back. Oh, don't know if that's going to work. It's just feeling very thick in this one. Tried something a little different here, and I'm thinking it didn't work, but we'll see. Might not be able to like save it, but... So what's been going on there is once you get the alligator clips in, it's hard to get it to snap on. It just wanted to slide around, so I thought, okay, I'm going to try to like stick it on first. But then you need to really wrap it in there so it's really well attached. And yeah, I'm trying to basically, get it set up so that it's easier to make several of them consistent quality. Yeah. Let's test the circuit. So circuit still works fine. It's pretty well. It feels heavy enough. Three of them on that I have so far. So now you can see that I've got the beginning of this sort of pseudo glove. It still feels way better than the other glove itself. So it'll be interesting to see how this works once I'm going. You know what? I'm going to use a different one for the thumb. It's just too tight, and it's way too loose for that side. Okay, so for my little finger, I have to try doing it with. Let's try a different finger. Yeah. with the bend in it, it's going to have to be like right at the tip of the wrist. There's no way it can be any further than that. Okay. So whatever I'm going to do there, and I have an idea, it's going to need to be tight enough that it stays right at the, right here, clips almost. I have an idea what we're using the material, so we'll see. Let's test it. Okay, so they're all working. There we go. There's my new improved touchpad. Now I need to make the thumb, and then I need to make a wrist attachment of some type. Connect all those together on it, so that I can easily move that around. Right. Okay, so for thumb, just cut that open enough. Let's see how it looks. Maybe. Encapsulated. Well, I'm not going to fit that in there. Awkward. But it only needs to work once. Great. So all of them work, and now the next step is going to be figuring out what to do for a thumb. Which one comes for the wrist part. Great. So just to kind of keep you guys posted, I was able to find some of these little plastic cups, which are of course awful little things, these little single-use plastic materials which are awful for landfill. We keep them because they're great for paint and other stuff. We're a very creative family, so we keep that kind of stuff around. So I took one of those and I took or cut the bottom off of it, cut the rim off of it, and cut it that way so that now it can fit easily on my wrist. And my idea right now is I'm going to try to not just reinforce this, but it's very sharp, and you'll find that in fact plastics like this get very sharp edges on them, and they're not great that way. So I'm going to clean this up and try to turn it into something that I can use consistently, and I'll probably pad the bottom of it a little bit so it's softer, that kind of thing. Okay, great. You can see there that I've taken the fabric tape and I've actually wrapped it around both ways so that now it's got a nice spring to it, and I can easily snap that onto my wrist and it'll come off really nice and easy too. I've made it nice and round so I don't have any of those sharp edges there. So next I'm going to look at getting the wires to connect to it so that it basically stays almost fully harnessed. Not bad. It'd be better if I had a way to clip that on, but you know what? For my first test with it, this should work just fine. Actually, so that'll stay there. Now let's grab this makey. And it doesn't actually matter to me like which ones are attached to this, to which one right now. Eventually it will become more important, whether it's color coordinated or it's based on the sound or what other element. Connect those there. We'll turn that around that way so it's a little easier to. Okay, moment of truth is coming. Oops. Okay. Definitely gets like heavier as you start to have more and more on it, and of course, you know, in a perfect scenario that would be attached in some way. Right now that's not possible, but I could see how that was sort of a bit of the original plan. So here's what I have right now. I've got those. Let me click on the let's see if I can. Now that's interesting in that it's not easy. Oh. So I definitely need something that is spread out more. So the ground actually needs some work, but really, that works great. That works great. So that is a perfect example of how you can use some of these crafting materials to make some really, really interesting interactions. Now that you've had a chance to take a look at several different ways of doing the fabrication, let's focus on the makey interaction form storming. You want to be experimenting with materials and interactions. You want to be using the code from Activity 1 to connect and test your ideas, and also start testing affordances around you based on Project 1. Now jump in and start form storming.